Welcome to my channel. Today I will show you some theorem which says alternate segment theorem. This theorem is very useful in exam because so many problems are coming basis of this theorem. So let's first understand the theorem, and in a later stage I will discuss some of the problem related to this theorem. So this theorem says in a circle the angle formed by a tangent and a chord which passes through the touch point is equal to the angle formed by the same chord in alternate segment. So let me read it for you first. In a circle, angle formed by a tangent and the chord which passes through the touch point. Touch means on the touch point of the tangent. Means the tangent is touching the circle at what point? A chord being drawn keeping the same point and other point on the circle. Then the angle formed between the chord and the tangent is equal to the angle formed by that same chord in alternate segments. Means there is two segments which chord dividing the circle. One segment is smaller and the other segments is somewhat bigger. So the alternate segments, the angle from that chord, if I draw it, will be equal to the angle initially described. So if I draw the figure such a way, let us see what happened. That means if this is a circle, I can show you, and if a tangent being drawn like that, let us say this is P and Q and it is touching at point T, let us say, and a chord being drawn taking the same point and other point on the circle, then the angle from, let it be alpha, and if this chord is T and you can say Ts, let us say. Now the angle if I form with this chord on the other segment, this is the other alternate segment, this segments I am talking about, and the angle from here, let us say beta, then alpha is equal to beta, that has to be proved, and this can be established as a theorem, and you can straightway use this theorem or property in other sums where you will face this kind of situation. Okay. So let me start with this drawing itself. So if I concentrate on this part, you can say let us say let me draw the center first. Let me assume that this is the center O, and I will connect the center to the vertices of this triangle formed due to this angle formation with the chord. So, this could be a triangle. At this point, if I mark it as S T O, let us say V. So, this triangle form, and here the center O I am marking. So, this O to the vertices I am joining these points. So, here I can say few things are very much known to everybody, because this center to any point on the circle will represent the radius. So, that means OS equal to OT are the radius of the, this I can say straight away. Okay. And this OT is perpendicular to PQ, because we know the radius on any tangent contacting the same point are perpendicular to each other. So, that means that this is a radius, this is the tangent. So, this from the property these are already established. So, you can say. So, now if I concentrate on this triangle, these are the two equal arm of so this is a isosceles triangle. Okay. So, this angle to this angle are same. So, you can say the angle OTS equal to angle OST, these are equal. So, this can also be said. Now, another property of triangle of circle is that the angle formed at center is twice the angle formed at on the same chord. Angle formed at center is twice the angle formed at periphery. So, in that way angle SOT is equal to angle SVT. This is also a proven theorem that can be shown in other videos. So, as of now you can just keep it in mind, the angle formed at center is twice the angle formed at periphery on the same chord. So, this can be said also already. So, from this triangle, if I concentrate on a triangle TOS, this angle plus this angle plus this angle is 180 degree. Okay. So, angle SOT is nothing but 180 minus twice of this, I can say twice of angle OTS, because this angle are same. This is isosceles triangle, as these are representing the radius. So, this triangle is isosceles. So, this base angle are same. So, instead of writing this plus this plus this, I am writing this plus this, twice of this is 180. So, only if I want to calculate this one, this is equal to 180 minus twice of this. Now, from the, as because this is 90 degree, as because the radius is perpendicular to the tangent. So, this total angle is 90 degree. So, from here I can say this angle plus alpha as per the theorem. So, alpha plus angle OTS is equal to 90 degree. So, from there you can say OTS is equal to 90 minus alpha. Okay. This is one establishment already established. So, this is another one that I have established. Okay. So, from there I can say on the top, from this equation I can say the angle SOT is equal to nothing but 180 minus, if I replace OTS by this is 2 into 90 minus alpha. From there I can say this is nothing but 2 alpha. That means this angle is nothing but 2 alpha. Now, again SOT I know, SOT is the angle at center, this is twice of angle at periphery. So, this is if I say 2 beta SOT, first I have to write 2 of angle SVT, that is equal to 2 alpha. From there 2 SVT, as per the theorem it is said as it is angle beta. So, 2 beta. So, both side 2 cancelled out, this becomes nothing but beta equal to alpha. So, hence prove your theorem, as this is called the alternate segment theorem, where the angle formed by a chord with a tangent is equal to the angle formed at alternate segments. So, this angle. So, this proves your theorem. So, thank you for now. Please keep a watch on, you see the total theorem and try to understand. Just follow my words, and if in case any doubt, please put it in your comment section so that I can clarify. Thank you for now. Please share and subscribe my channel.